My name is Nicolas Tempels, and I'm here to tell you about my summer undergraduate research experience. First, I'll tell you a little bit about how I got involved in the SURE program, and then I'll tell you about my experience. So my reasons for wanting to do research are twofold. First of all, I'm a senior, and I'll be attending grad school, hopefully, so I wanted to get a feel for what that would be like. Second, my previous two internship experiences were mediocre, and I thought that research would be a better fit for me. So I talked to one of my professors, Professor Amy Cohn in the IUE department, and she suggested that I sign up for the SURE program, so I did. Now, let me give you a little information about what I did this summer. I worked on a couple different projects, but my main one was wind farm network design. And this problem is about deciding where to build wind farms and how and where to send the power so as to satisfy a given demand at different load points. My three main contributions to the project were to gather extensive sets of data, help refine an algorithm developed by Professor Cohn, and put together presentations on how power transmission works. The data I recorded came from a public website containing a year's worth of real-time data of wind speed and wind power collected at 10-minute intervals for over 30,000 wind sites on the western side of the country. My job was to take a descriptive sample of those sites, organize the data so that they could be passed into a simulation. Test and prune is the unofficial name of the algorithm developed to solve very large linear programs that have a certain structure. In brief, it consists of enumerating all possible combinations, randomly testing one, and using that information to prune other combinations in the list until only the optimal solution is left. I worked on a way to solve this faster by the concept of granularity. This allows us to center in on the optimal solution by finding a range of combinations that could contain that optimal solution. Doing this results in a much more efficient method of solving very large, complex problems. And while working on this algorithm, we had to consider its application to other problems, so we had to design it so it would be robust and flexible. The wind problem requires the modeling of how power is transported from supply to demand. My job was to research this and put together a simple presentation. I also reviewed basic electricity concepts that could be useful in the model. More specifically, we had to understand how power is lost and how much of it is lost during long-distance transmission. That about sums up my research experience. Good luck with yours.